So let's talk about how do we find the following limits, right? So we're going to find the limit as f of x approaches 1, as it approaches -1 from the left, and as it approaches -1 from the right. They also want us to verify the vertical asymptotes, which we will do using some graphing here. So we want to find these limits. So when it does come to finding the limit of a function, we do want to try plugging in that value that it approaches. So this says x does approach 1. So we would want to try plugging in 1. Now, I typically always start with plugging it in the denominator. And if we plug in 1 in the denominator, we see we'll get 1 squared minus 1. That's really just 1 minus 1, which is 0. So we do see this would get 0 in the denominator, which would make it undefined. So we do know that this function is undefined at 1, right? Because if we plug in a 1, again, we get 1 minus 1, 0. You don't want 0 in the denominator. So that means that this graph should have a hole at 1. Now, since 1 didn't work, we do want to see if we can tweak our example here, simplify it, break it down. Now, this is a polynomial function in our numerator and our denominator. So it is a rational function, but we have polynomials for our numerator and our denominator, which means typically factoring will work here. Our numerator, if we take a look at our numerator, that does factor to x minus 1 times x minus 3. Our denominator is actually the difference of squares formula. That is an x plus 1 times x minus 1, which means we have x minus 1 in our denominator, x minus 1 in our numerator that we can cancel out, leaving us with an x minus 3 in our numerator and an x plus 1 in our denominator. Now, at this point, we can plug in and find the limit of this analytically here. So if we want the limit as x approaches 1, now, if we go ahead and plug in a 1 at this point, we will be left with a 1 minus a 3, which is a -2, a 1 plus 1 in the denominator, which is a +2. So it does simplify to a -1. So that means the limit as x approaches 1 is a -1. When we take a look at the limit as x approaches -1 from the left, so again, we want to go ahead and plug in a -1 into our function. -1 times -1 is a +1, and 1 minus 1 is 0. So we get a 0 in our denominator when plugging in a -1, which again means that we want to take this, we want to break it down. Now, since we are working with the same function for all three of these, we are using the same f of x, we can go ahead, use the same factoring, and know that this is x minus 3 over x plus 1. Now we're plugging in a -1 here. But if we plug in a -1 into the denominator, we get -1 plus 1, which is 0. So we are going to determine this analytically here. So as x approaches -1 from the left, we are going to plug in a -1 into the numerator. That gives us a -1 minus 3, which is a -4. So the numerator approaches a -4. In the denominator, we're not just going to plug in a -1, we are plugging in a -1 from the left-hand side. So we want to plug in like a -1.1, right? Something directly to the left of -1. If we do that, we are left with a -0.1. So our denominator is negative. So if your numerator is negative, your denominator is negative. Negative over negative is positive. And again, if you have a super small denominator like we do here, the smaller your denominator is, the larger your function is. And rules of limits say, based off our sign, if our denominator is small, that makes your function go larger and larger and larger. So since it's positive and growing large, we can say that this limit is going to be a positive infinity. For the third one, very, very similar here. Again, we're using the same function, so we can say x minus 3 over x plus 1. This time we are plugging in -1 from the right-hand side. So if we're using -1 from the right-hand side, we want to think like -0.9. So if we put like -0.9 plus 1 in our denominator, we are left with a positive 0.1. If we plug in a negative 1 into our numerator, we do get a negative 4. So look at your signs. Numerator is negative, denominator is positive. Negative over positive is negative. And again, with the small denominator, your function grows large. And rules of limits say that if the function grows large and it is negative, it is going to approach negative infinity.